Welcome to 7 Steps of Instrumentation Roadmap webinar. In this webinar, we're going to talk about 7 steps you must get familiar with to become a professional instrument engineer. I will reveal the exact way that I passed and led me to success in this field. For sure, I experienced dozens of challenges in my career, and I decided to design a roadmap of learning that gives you a big picture of instrumentation. By this view, you can improve your job more quickly. So, enter your email address to send more helpful content. Now, before we start revealing our 7 steps, let's give you a quick overview of what you can expect in this training. First off, this training will be about an hour long, jam-packed with value, so get your notepads ready. For the first few minutes, I will be giving you a quick background about who I am and how I got started in this profession. Then, for about half an hour, I will be giving you 7 steps in learning instrumentation, and I won't speak about the paid course the whole time. Make sure you watch all these 7 steps because they are totally practical, especially the last 2 steps. Then, for about 5 minutes, I will be explaining about the paid course for the people who want to learn more beyond this free training, and also offering an exclusive discount for everyone who sticks until the end of training. And in the last 15 minutes, I'll be answering a long list of frequently asked questions, many of which I'm sure you will have. So, you don't want to miss that part either. May some of you know me. My name is Farzad Lutfi, the industrial consultant and instrumentation trainer. Let me tell you my story. I started my career in 2005. I was confused with the subject and it made me disappointed because I didn't know how I should start. It took me a year to study reference books like Measurement and Safety, Lessons in Industrial Instrumentation and Process Control, and for sure, many manufacturers' catalogs. But they were really boring and I felt I was wasting my time. I spent several years working in this practical field, so gradually learned what requirements I was asked. In 2010, I'd been working in refineries, petrochemicals, and I knew how I designed, installed, and worked with all instruments. Since I'm highly interested in teaching and sharing my knowledge to others, I started training the technicians and engineers in 2011. With the passage of time, I was increasing my practical experience in different industries such as oil and gas, petrochemical, steel, mine, and power plant. And now I can tell you I've trained more than 3,000 engineers and technicians all over the world. I was also invited by a couple of big companies to train their technical work staff. As a result of that preset experience, I designed a learning format to teach an engineer how to become a pro in a short time. I call this method InStart, which means Instrumentation Start. In this webinar, I'm gonna reveal the learning formula in 7 steps. I personally think that there are 6 problems that make this major hard for becoming a pro. First, the ones who want to start this job don't know what they should learn at first. Second, most of references have been written based on theory but not practical. Third, most references are too long to study. Fourth, diversity of information on the internet is too much, so it makes it time-consuming to learn. Fifth, working with an instrument based on try and error causes damages. Sixth, attending the workshop costs too much, they're forgettable and non-effective. And the most important one, in the technical world, your professional colleagues may not transfer their experience to you easily. Now, let's dive into the 7 steps InStart roadmap. As the first step, I'm gonna start with basic definitions and standards. As you may know, for designing and selecting a suitable instrument, we do need to follow a reference called as standard. There are a lot of standards published in the world, and we can apply to design and choose the device. An example could clarify this issue. IEC 60529 is applied to choose the ingress protection grade. or IEC 60079 is used to design the suitable explosion-proof type according to hazardous area classification of the industrial plant. Also, an instrument engineer must have enough knowledge to choose the appropriate construction material for a device. I can tell you the part of instrument exposed to fluid is called the wetted part. The suitable material for this part is considered as stainless steel 316 as minimum. The body, housing of the instrument might be die-cast aluminum. Let's continue with the second step. To begin with, I need to emphasize that this step is the most important one and you should spend a great amount of time practicing and training for it. This part is instrument measuring devices. 4 quantities, which are pressure, temperature, flow, and level, are considered in this section. There are 3 types of instrumentation which play important roles. The gauges measure the amount mechanically. Not only the transmitters measure the amount, but also send it as a signal to the control room to indicate it on a computer or display. And the last one, which is switches used for protection. When it comes to pressure, the most famous measuring element for gauge is board and tube, particularly C-type. There are many accessories for a gauge such as diaphragm seal, two-way valve manifold, and siphon use it in hot steam services. For designing and selecting a pressure transmitter, you need to bear in your mind that accuracy is a vital factor and it's usually considered better than 0.5% of full span. To calibrate a pressure transmitter, you would apply a heart communicator, a hand pump, and a multimeter. To clarify, heart is a typical protocol applied to communicate with an instrument. Let's put calibration aside and deal with their installation. In most applications, pressure transmitters are installed further than pipe. With the help of tubing from the tap on the pipe, we are able to install the pressure transmitter. Be notified that if the fluid is liquid, you must locate the transmitter lower than the pipe tap, while for gas services, we'll locate it on top elevation. Sometimes you deal with steam and vapor. Since this fluid is likely to be condensed, you should use a steam trap, also known as a seal pot. There are 2 important accessories for these transmitters, which are two-way valve manifold and the diaphragm seal. Diaphragm seals are usually used to create isolation between the measuring instruments and the fluid, which is corrosive or high viscous. The transmitters are installed on diaphragm seals directly, or may you apply a capillary tube for its mounting. In some special cases, you might use a differential pressure gauge or transmitter. A practical example is a filter or strainer. An operator working in an industrial plant must know the difference between the inlet and outlet of a filter to clean it periodically. You should be notified that the instruments in this category are installed with the help of a 5-way valve manifold. About temperature measurement, I would draw your attention to the measuring element of a gauge, which is bimetal. Besides, we might apply the RTD or NTC or even thermocouple when we use a temperature transmitter. PT100 is the most well-known sensor, which is made from platinum. At 0 degree of centigrade, the electrical resistance is 100 ohm. That's why it is called as PT100. When the temperature reaches 100 degrees centigrade, the electrical resistance would be around 138.5 ohm. This sensor is useful to measure temperature less than 300 degrees. Because of its behavior, the relationship between electrical resistance and temperature change is completely linear. For temperature greater than 300 degrees centigrade, it is highly recommended to use thermocouples, which are designed to measure around 2000 degrees of centigrade. Type J and K and even S are the most famous types in industries. To install a temperature measuring device on a pipe or a tank, we must use a thermowell. It is a kind of sheath to protect the instrument. As you may expect, the construction material of a thermowell is stainless steel 316 as minimum. The type of connection can be fulfilled via flange or thread. To design a thermowell, wake frequency calculation is so important because the created frequency of vortices must not exceed 80% of natural frequency. Otherwise, the thermowell is broken due to resonance. Moreover, the tip of a thermowell must be located between 1/3 and 2/3 of pipe diameter in order to measure accurately. A way to reduce high wake frequency is to decrease the length of thermowell, or even you may apply special thermowell designation. Please bear in mind that if the pipe size is smaller than 4 inches, you have to expand the line size to install a thermowell. Sometimes installation with 45 degree is suggested as well. Undoubtedly, flow measuring principles could be a little bit complicated and you might spend enough time dealing with the different types of measuring devices. There are more than 50 methods to measure the flow based on differential pressure, velocity, or even mass. The simplest and most typical form of flow measuring is based on differential pressure. To do so, we utilize an orifice plate, venturi tube, or even pitot tube. This principle has less accuracy, but it is cheap. There are a lot of factors which you need to take into consideration to choose a suitable flow meter. I can say the fluid compositions, state of fluid, pressure and temperature, differential pressure, Reynolds number, accuracy, repeatability, pipe size, installation type, turn-down ratio, and so forth would have a direct relationship to select the best flow meter. Turn-down ratio, called rangeability, is the division of maximum amount of a device measured by its minimum. Surprisingly, ignoring one of these factors would have an awful effect on the measuring. As an example, magnetic type flow meters cannot measure the steam or gas, while thermal mass flow meters is the best choice to measure these services. Furthermore, magnetic type is applied for liquid whose conductivity factor is greater than 5 microsiemens per centimeter. To measure the flow of a fluid by means of a turbine flow meter, fluid must be clean without any particles. In the metering system, we deal with ultrasonic, Coriolis, positive displacement, and turbine flow meter. These instruments provide high accuracy and repeatability. To calculate the bore diameter of an orifice, ISO standard 5167 is applied. As an instrument engineer, you should be able to work with related software to do flow element sizing such as Conval and InstruCalc. The outcome of these softwares show the orifice bore diameter and beta ratio, which is the division of bore diameter divided by pipe internal diameter. By means of this relation and knowing the fitting insult on the flow element upstream, we are able to estimate the upstream length. You need to bear in mind that in many types of flow elements, fluid turbulence has an intense effect on measuring. Therefore, you need to consider suitable distance after a fitting like elbow, T, or reducer to let the fluid profile become laminar. Perhaps you have just come up with this question whether it is possible to install a flow meter on a vertical pipe or not. I can say yes, as long as the direction of flow has been checked. For liquid state, the flow direction must be upward. On the other hand, for gas services, it must be downward. We consider the flow direction in this way to keep the pipe full. Thus, the measuring is carried out more accurately. Level measuring instruments are another part of this section, which are used to measure the height of fluid in a tank or a vessel. There are a variety of methods to measure this amount, such as differential pressure, ultrasonic waves, electromagnetic waves, and buoyancy principle discovered by Archimedes in past centuries. As the simplest method, sight glasses would be used. Sight glass is categorized into 4 subsets: tubular, reflex, which is used for bright color fluid, transparent, which is used for dark color fluid, and magnetic type. You should be informed that the transparent type is equipped with an illuminator to be seen at night clearly. The side glass is connected to the vessel with the help of two piping isolation valves with the size of 2 inches. The flange rating is usually 300 pounds and the flange face is raised face. For this level column, level gauge, we should install a vent and a drain valves to make the column empty during maintenance. The size of these valves is usually 3/4 inches or even 1 inch. For sure, the length of this column has limitations and you are not able to design it in longer dimensions. Just imagine there is a tank with a height of 6 meters and now the length of the level gauge column is just 2 meters. It is clear that you do need 3 columns to measure the height of the tank. In this regard, we consider a pipe called as standpipe on a tank. Then those 3 level gauges are installed on this standpipe. Undoubtedly, considering the overlap between columns must be considered. Looking at my previous speech, may you remember that differential pressure transmitters are really handy and versatile to measure flow and pressure drop. In order to measure the level, we can also apply them. We know the density of the fluid inside of the tank, then we're able to calculate the height based on the pressure column of fluid inside of the tank. By means of 2 tubes, we connect the nozzles to a 5-way valve manifold and differential pressure transmitter. As you may see, the upper leg is dry because there is no fluid passing through. In some applications where the vapor of fluid might accumulate on top of the tank, a steam trap or seal pod is mandatory to install. Otherwise, the vapor would enter the upper leg and become condensed and make a pressure column which leads to error in instrument. On this occasion only, the upper leg would be filled by water or glycol. Therefore, this leg is known as wet leg. Another method of level measurement is displacer type, which is based on buoyancy force. This type would be really helpful when there is an interface between 2 fluids. Just imagine a separator which is designed to separate oil and water. Since the density of water is greater than oil, water stays lower. To measure the height of water, we are able to install a displacer level meter on a separator, and the time the displacer weight is about to decrease, it is deduced that the height of water becomes higher. As I mentioned before, ultrasonic waves are highly applied in level measurement. The ultrasonic level meters do not have high accuracy. Hence, they are used for simple and not valuable fluids. Installation of these sensors require many considerations. For instance, the existence of foam on the surface of fluid, dust or vapor on top of the tank would have an awful effect on the accuracy and may make the sensor blind. On the other hand, radar level meters do not have the pre-mentioned limitations and we may cope with the obstacles by these level meters. Level switches are widely used in different industries to protect a vessel or a drum from overflow. You can design a drum and consider a set point for the highest level called high. A floater level switch or a tuning fork type could be installed on the elevation, and in case of fluid reaching, the related contact is changed. If the electrical contact used to be a normal closed one, it changes to open. Consequently, this digital signal is sent to the control room and the operator supervising the system is informed of the high status at the site. Let me put the measuring devices aside and continue with the 3rd step. When it comes to industrial valves, you cannot imagine how exciting they are. I personally suppose that this part of instrumentation makes an engineer interested to study and practice this field. Generally speaking, these valves could be categorized into 3 main subsets, which are control valves, on and off valves, and pressure safety valves. I'm gonna begin my words with control valves. These valves are applied when we want to control a specific quantity such as flow, pressure, temperature, or even level. By means of creating a differential pressure, the valve can control the amount of flow passing through a pipe. The best valve for this application is a globe valve. However, it has some constraints such as low capacity and limitation in size. Besides, they are too expensive. In some applications, ball valves, plug valves, butterfly valves, and even eccentric discs might be replaced with a globe valve. Valve body material is usually constructed with carbon steel and its standard is ASTM A216 WCB, which is cast carbon steel. The internal parts where exposed to the fluid are called valve trim, and it is often made of stainless steel 316. Globe valve is also known as a sliding valve due to moving vertically. A plug would close the path of flow which moves through the valve port. The further the plug is from the seat, the more flow can pass through a valve. As I explained before, a control valve creates a delta P. As a result, flow could be controlled. One of the most important factors to design a valve is that the downstream pressure, the outlet valve pressure, must not be less than fluid vapor pressure. Otherwise, fluid is vaporized inside of the valve and formed bubbles which move with high velocity cause a lot of damage for valve trim. This severe service is known as cavitation phenomenon. Since there is a direct relationship between noise and velocity, we come to expect that in this condition the created noise is being increased. As a point, the maximum sound permitted level is just 85 decibel in 1 meter distance from a valve. There are some solutions to remove cavitation. For instance, we might apply a restriction orifice after a control valve and assign a portion of delta P to it. Sometimes cavitation is inevitable, thus we have to use slided stainless steel for valve trim material to strengthen against the cavitation effect. In addition, we can use cage to reduce the created noise. Not only the cage really helpful in noise reduction, but also it can specify a valve characteristics, whether it is linear, equal percentage, or quick opening. With the help of different cage shapes or seat and plug forms, a desired valve characteristic is made. An instrument engineer must have enough knowledge to calculate the CV coefficient of a control valve. To do so, some software is applied such as Convol, InstruCalc, and so forth. The greater CV, the greater valve size and capacity. To implement the force to open and close a valve, we apply an actuator. The force can be generated by means of pneumatic instrument air, hydraulic, motor rotation called as MOV, or electrical. The most typical actuator for control valve is diaphragm type. In case of air applied, a spring located underneath the diaphragm is compressed and the force transfers to the valve stem. In case of air failure, a spring returns back and it makes the valve fail to open or fail to close. Undoubtedly, positioner is an integral part of a control valve. Actually, a positioner determines the exact position of a valve, which can be between 20% up to 80%. It is not usual to close a control valve less than 20% or even open more than 80%. The positioners have two different entries. The first one is a control electrical signal which is sent from the control room and it is a 4 to 20 mA signal. The second one is a pneumatic line with approximately 6 bar pressure. A converter in positioner plays the role of transforming the electrical signal to the pneumatic signal. That's why this converter is known as an I2P converter. The outlet of the positioner carrying the pressurized control air is introduced to the actuator. You need to bear in mind that to supply a control valve, some tests must be carried out by the manufacturer and the results of each are reflected in a report. The first important one is called as shell test, in which the valve is partially open and the pressure of the test is around 1.5 times greater than design pressure. Leakage class test, function test, and backseat test are some other types which are necessary for a control valve. The second type of valve is on and off valve. As it is thoroughly clear from its name, this valve plays an important role to block or isolate a pipe. Ball valves, plug valves, and butterfly valves are frequently used for this reason. Piston-type actuator is widely used to close or open a rotary valve like ball or butterfly. This actuator can be single-acting, spring-opposed, or double-acting, where there is no spring to return the actuator back. When the instrument air is applied to a piston, the Scotch plays the main role to transform the axial movement to the rotary action. Generally speaking, the leakage class for the on and off valve must be selected from higher classes, 5 or 6. On and off valve size is equal to pipe size. It is different from the control valve size, which is always smaller than pipe size. In special applications where explosive fluid is passing through the pipe, the on and off valve must be designed fire-safe. In this regard, the seats are designed in a way that can provide the highest rate isolation in spite of burning the soft seat. I've just said soft seat. It means the body of the seat is made from a metal like stainless steel 316 or carbon steel ASTM A105. Then a layer of a non-metallic material such as nylon, Teflon, or even graphite sticks on the surface of the seat. As you know, ball material is stainless steel or carbon steel, and it rotates on a soft material like Teflon. We can get a result that the leakage is near to zero in this regard as compared to the time we use metal seats. When the seat is metal one, due to the friction between two objects, ball and seat, it is too difficult to manufacture a valve with high leakage class. However, there are some manufacturers who produce metal seat valves with leakage class 6 exceptionally. But even these valves have not been produced in large size yet. Last but not least, a soft seat valve requires considering an anti-static device. In short, an anti-static device used in a ball valve is to reduce the static charge generated on the ball due to friction. It is used to protect the valve against spark that may ignite the fuel flowing through the valve. The ball valve with an anti-static design is especially for the field like oil and gas, chemical, power plant, and other industries that fire-free is important guarantee of safe production. The third type of valve is PSV or pressure safety valve. These valves perform mechanically. With the help of a spring and adjusting screw, we are able to assign a pressure set point to that. The time that the process pressure reaches its set point, the valve opens and the excess pressure releases out. This type of valve protects the equipment such as drum, vessel from overpressure and blasting. The inlet size is always considered smaller than the outlet size. This valve is categorized into 3 subsets, which are conventional type, balanced billows type, and pilot-operated one. One of the most factors to select the appropriate type is back pressure amount. For instance, if back pressure is less than 10% of set point, conventional type is chosen. The PSV contains 2 main parts, body and the bonnet. The inlet nozzle could be categorized to semi and full nozzles. I personally offer the full nozzle one because, as you can see, full nozzle can be extracted from the body, and in other words, it is changeable. The cross-section of releasing is calculated by some special software, so as an instrument engineer, you must have the ability to calculate the discharge area and choose the best selected area for a PSV. There is a ring around the PSV seat known as blow-down ring. It is always locked by a pin accessible on PSV body. In broad terms, spring specifies when PSV opens and blow-down ring determines when PSV closes. PSV bonnet might be open or closed. In some applications, such as hot steam services, we tend to consider an open bonnet to let the spring be exposed to the air in order to reduce the heat radiation. For sure, in toxic or corrosive services, you are not permitted to use an open one because in case of possible leakage, it poses a lot of dangers to the environment. Same as many other devices, PSV might be supplied with some accessories. you may select a lifting device, a lever, for a PSV. Sometimes we do need to check the opening performance of PSV deliberately to ensure that the valve has not get stuck or jammed. Finally, I would like to state that there are many points and tips about valve which you need to consider for designing, sizing, and supplying. In the fourth step, you get familiar with installation fittings and wiring equipment. Let's begin with hookup fittings. There are several types of fitting applied to install a measuring instrument on a pipe or a vessel. For example, for mounting a DP-type flow meter, we need tubes, union, male connectors, T-connectors, and plugs. In the designing stage, this is an instrument engineer's responsibility to draw a precise hookup drawing and then count the material takeoff or bill of material for all fittings. In the construction stage, a contractor would follow the drawing design in the engineering stage and install the measuring instrument on its tap. To design the hookup drawings, an instrument engineer needs to have enough experience and knowledge to implement all the drawings. After all, when it comes to wiring and termination, we face junction boxes, cable glands, and instrument control cables. To design an appropriate JB, bear in mind that the single cables related to measuring instruments should be entered from the left and right side of JB symmetrically, while the multi-cables which integrates all signals and transfers to the control room must be extracted from the bottom. JB construction material should be die-cast aluminum or stainless steel, and the amount of copper is not allowed to exceed more than 0.4%. IP degree should be 65 at least, and explosion-proof certificate for JB is required from the manufacturer if it is installed in a hazardous area. To fix a cable on the junction box, cable gland is used. It can tighten on a junction box by its thread connection or a lock nut. For measuring instruments which always send an analog signal to control rooms, a single pair cable is used. In this type of cable, two wires are twisted and there is bare drain wire alongside it. An aluminum shield covers all the preset wires to protect the cable from radio frequency and interference noise. A two-core single cable is used for transferring the status of switches to the control room. The main difference from the pair cable is that these cables do not have drain wire and shield. To protect the cables from mechanical damage, the armor layer might be added on cable inner sheath. Last but not least, the cable outer sheath is usually made from PVC and it must be halogen-free. Some cables designed for fire and gas application are fire resistant. It means they are able to transfer the signal in case of fire. For instance, they can resist 800 degrees of centigrade within 90 minutes. During this period, the signal must not fail. In the fifth step, we're dealing with one of the most vital items. For sure, safety requirements are the main prerequisite to start any industrial job. In this section, there are many obligations and rules which we need to bear in our mind. Explosion-proof standard, gas group, temperature group, and IP standard must be applied to design a field instrument. For instance, in operational zone 0, we must apply an instrument certified with intrinsically safe explosion-proof type, EXI, based on IEC 60079 Section 11 standard. Another example is related to the battery room where the hydrogen gas emission exists. If we want to choose an H2 gas detector for this place, we must use 2C certified detector. Fire and gas devices are discussed in this section too. We are dealing with a gas detector, flame detector, heat detector, and smoke detector to alert the operators when the flame or gas exists. Moreover, some other equipment such as manual call point, acoustical sounder, and flasher are applied as well. Let's take a short glimpse on the cause and effect of this system. Toxic gas detection like H2S gas detectors is mandatory to give an early warning to operators to escape. Particularly, they might be installed on HVAC system entry. Combustible gas detection, such as CH4 gas detectors, is compulsory to give a reliable alarm or signal to protect the equipment, just like a gas turbine enclosure. Finally, in case of fire detection, the detectors send a reliable alarm or signal to activate the firefighting system. Gas detectors are categorized into two subsets: catalytic and infrared type. Catalytic one is more applicable when the ambient temperature is higher than 60 degrees centigrade, like a gas turbine enclosure. Infrared type sensors have fast response time. On the other hand, they cannot be used in places where there is dust in the air. To install a gas detector, you need to know the composition of the gas. For instance, since methane is lighter than the air, CH4 gas detectors shall be installed on top elevation. Heat detectors are divided into two major types: fixed point and rate of rise. The first one is activated when the process temperature reaches its set point, while the rate of rise sensors performs based on the temperature increment within a minute. To detect the flame, ultraviolet or infrared waves could be applied for flame detectors. UV detectors might be used to detect non-hydrocarbon fire, while the IR sensors can detect hydrocarbon one. These sensors have pros and cons too. I can say that UV sensors are sensitive to sun radiation, and IR detectors might detect gamma or X-ray as fire. To minimize false alarm due to sunlight or other radiant energy, it is highly recommended to use the combination of both waves, UV-IR flame detectors. About warning devices, the sound made by outdoor acoustical sounder must be at least 110 decibel, and flashers must be xenon type, and its illumination must not less than 65 candles. Moreover, the cone of vision is 360 degrees. In the sixth step, we're dealing with a really interesting specialty, which is calibration. This subject guarantees the performance of the field instrument and their accuracy. We all know that the field instrument lose their accuracy with the passage of time. Less accuracy causes a lot of unexpected consequences in a process. I can draw a practical example to clarify this matter for you. You can imagine a control valve which is controlled by a pressure transmitter signal. The measuring range is 0 to 10 bar and output signal is just 4 to 20 milliampere. Unfortunately, this transmitter has not been calibrated for a long time. Therefore, the accuracy has decreased from 0.5% to 2%. The valve used to open 50% as a result of the 12 milliampere signal, but now it does not happen. Why? Because the pressure transmitter cannot measure 5 bar accurately. To carry out the calibration procedure, not only do you need some reference calibrators, but also you must get familiar with the different kinds of errors. Deadweight testers, gauge comparator, hand pumps, hard communicator, milliampere source, and devices like them are widely used in calibration. The most well-known errors which may happen for an instrument are zero shift and span error. Before starting the calibration procedure, you need to prepare a table in which the points of calibration must be written. For instance, 0%, 25%, 50%, 75%, and 100% are written. Then you need to check the measuring amount in each point. After that, the difference between real and expected measuring amount specifies the action to take. In the last step of learning instrument engineering, the seventh step, you need to know how you design and prepare engineering documents. The most typical one is the datasheet, in which all technical and general points of an instrument are stated. For each instrument, a specific datasheet must be prepared. To design and fill a datasheet, you need to have some prerequisites such as P&ID diagram, piping material specification, PMS document, technical specification, and project design criteria. I mentioned P&ID in my last words. It stands for Piping and Instrument Diagram. As an instrumentation engineer, you should get familiar with all symbols and legends of this diagram. Moreover, you must be able to survey the document in detail and find the relationship between the field instrument and comprehend the control loops and logics. There are some other documents which are always published to specify the connection between the field instrument and control system. Cable list is a document in which all cables laid in a project are specified. I/O list, which is the most important document to design a control system, is prepared to show how many input and output signals exist in a project. Wiring and termination diagram is a construction type document in which the connection of each field instrument with a related junction box is drawn. Cause and effect matrix is a document in which the effects of the group of signal on others are marked. For example, a level switch or a pressure switch signal on a vessel can close the inlet valve. Looking at my last words, you clearly remember that I explained about some calculation software, specifically in flow and flow sections. Sizing documents would reflect the result or outcome of those software. There are certainly some other documents, but I've just put my fingers on the most well-known ones. An instrument engineer should be specialized in document preparation as well. Well, now the 7 steps roadmap that I presented was brought in Instart, including 90 hours training with all details. By Instart, you will learn different methods of designing, all measuring devices and their performance, standards and practical workshop to install, calibrating, and troubleshooting. Instart contains 15 main sections. These sections are presented in different workshops and sent with the help of thousands of photos and movies which I myself took in the project that I was cooperating with during the last decades. Some of the members strongly claimed the skills that they learned by Instart were more valuable than the semesters at the college. The average salary of an instrumentation engineer in the United States is $70,000, and if you search the job vacancies on the internet, you find out that there are always a lot of job opportunities. All the job requirements that you must know to get the job were covered in Instart content. So don't forget that having Instart is a type of investment, and certainly you'll be able to find the deep effect of it on your success to get your desired career. Here are some of our members' opinions about success in their career after training by Instart. Vad Kolji said, "I was completely confused at the beginning of my career in an oil company. I had to ask my technical questions from my colleagues and made them really annoyed. One day, one of my managers introduced Instart, and incredibly, after just 1 month, I was surprisingly changed. My colleagues were curious to find out my turning point." Rosa Marison wrote for us, "I was working in a small company with low income. I was dreaming of working in a big and well-known company, but I couldn't because I didn't have much experience. I overheard about Instart and then bought it. Now guess what? I'm paid $5,000 monthly in a new company." Instart training package includes 80 hours recorded videos in 15 sections containing 2,000 photos and technical clips. 10 hours workshop where I worked with more than 100 instrumentation devices and calibrated them. Access to all future contents. Access to exclusive community. So as far as pricing goes, a lot of colleges and institutes will currently charge you between $5,000 to $20,000 to teach you for similar practical course or mentorship programs. And we personally feel our product is more in-depth and has easier to follow the instruction videos than most products in this engineering field. Yet to become this program is affordable for anyone, we will be selling it for just $2,000, but we are still in the growing stage of this course. We're gonna sell the Instart with 50% discount. And for the ones who are watching this webinar to the end, we will be offering an additional discount of 20% off. So you can join today just with this price until next 15 minutes. And you can take advantage of discount offer by exiting the landscape mode and clicking on the offer on your screen, or using the coupon code that you see on your screen at checkout. We developed this course for a year and continue to update it ongoing. We understand that for some of you it is pricey, but you need to look at this as an investment, because that is exactly what it is. You are investing in education that you can potentially increase your income by force, if not thousands of dollars over the following years. So there is 20% off on the table now to help you start your professional career today. Now, as I promised, I'm gonna answer some of your frequently asked questions that you may have in this point. The first question is, does it have any guarantee? Sure it does. All payment is completely refundable during 30 days without any reasons from the clients. The rate of satisfaction of 97% is absolutely eye-catching. Next question, do I need a prerequisite to learn this package? Instrument engineering is based on the needs of the industry and is not just an academic course. It is really interesting for you to hear that some people working in this field even didn't pass any academic course at university or even college. Our instrument training is completely based on basic and practical concepts and does not require any other scientific prerequisites. Therefore, you can be sure that even if you have not got any prior knowledge, you can keep pace with InStart because all parts were designed from basic level and you can reach the advanced level. I want to emphasize that all things from A to Z can be found in InStart. Familiarity with the concepts of control and industrial automation can improve your speed along this path. There is another question. After learning this package, are we able to do projects and apply for job vacancies? This question has been asked by many applicants for this package. It should be noted that all training is based on the concepts used in the industry, and you can easily pass the course to work in various industries like oil and gas, power plant, steel, and so on. I need to mention that again, all sections of InStart were designed based on the industrial projects requirements, so it gives you this chance to prepare yourself professionally for your desired job. What documents are taught in document preparation section? This part undoubtedly is one of the most wonderful sections of InStart. In this part, we will cover all the documents that you deal with in the instrumentation engineering department. Documents like temperature, pressure, flow level datasheets, prepare the RFS datasheets and do the calculation by special software, datasheet for all types of valves such as control valve, pressure safety valve, and do the calculation software, P&ID survey, material requisition, I&O list, preparation of location layout document, preparation of cable lease schedule, preparation of wiring diagram, cause and effect chart, and so forth. Next question, is the calibration training of this package practical? Same as all parts of InStart, first I teach you the related theory and how to calculate the error and uncertainty. Then I will take you to a workshop and there you can see how I calibrate an instrument practically. Do I need to work with the instrument practically? For sure, working with an instrument could be rewarding and it helps learning more. But do not forget that to work with an instrument, you need to know the basic procedure and prerequisites. InStart target is to guide you to do this precisely and based on adequate knowledge. Next question is, I studied mechanical engineering at university. Is this training package useful for me? It is worthwhile to say that instrumentation engineering is a multidisciplinary field. I mean, there are a lot of interfaces between instruments and other engineering fields such as piping, mechanic, process, and things like that. An example might clarify this matter. Imagine you want to install a measuring device on a pipe. For sure, you must have enough knowledge about construction material, fluid state, its profile, and composition. As you can see, This major would attract the mechanic and process engineers due to the concepts and including many relevant parts. Is there a good labor market for this field? When you take a look at different industries such as oil and gas, steel, mine, chemical, food, and power plant, and so on, you can find it any of them there is a process which needs to be controlled. Certainly, to control a process, we need to measure the different parameters of fluid passing through a pipe or in a tank. Therefore, instrumentation engineering has been always known as a high-demand one. If I have any questions while I'm watching the training, what should I do? As soon as you get the package, you will be added to a Facebook private group, and there I will answer all your questions and solve your problems. Besides, you have this opportunity to have other members' points of view about your matter. Is it an online training course or a recorded one? As I mentioned before, my team and I recorded all parts of Instart in a professional film studio, and it took us a year. All parts of this video training package is full HD, and it includes 90 hours training. It has lifetime access, and you can watch this video anytime and anywhere. Shall we learn how to design, or is it just practical? Based on related standards, I teach you all designing points to select the best instrument for the process. Then I compare the different types of devices, and you will learn the pros and cons of each. How much improvement would I get if I watch Instart? I always describe Instart as a shortcut because it accelerates you in this career. If you want to hear numbers, I can say at least you get experience for 3 or 4 years. If it had been an Instart when I started my career, definitely I would have bought it. How can I pay? You can easily add the Instart to your shopping cart through our website. After entering your detailed information, you will be transferred to the payment stage. Complete your purchase with a credit card, and the training download link will be sent to you at the end. Okay, our free training webinar is about to wrap up. If you still want to join but you have problem with payment, or maybe you need more weeks to save more cash, should you send an email to this address. And if you have any other questions about instrumentation jobs and Instart package, please don't hesitate to ask in our website comment section. Thanks for being with us until the end of this webinar. We wish the best luck for you.